Morning. In today's lesson, lesson 3.5, the title of our lesson is Model with Arrays, and we are on page 119 of your textbook. And our essential question today is, how can you use arrays to model multiplication and find factors? So let's look at the unlock the problem. Many people grow tomatoes in their gardens. Lee plants 3 rows of tomatoes with 6 plants in each row. How many tomato plants are there? Okay, so in this activity it says we should use square tiles and a math word. We can use our writing area here to show our array. So we really don't need that math word. If you want, find something that has, you can use anything as counters. For instance, I can use pennies to represent the rows. Okay, so it said 3 rows, and in each row there are 6 plants. Okay, so that's 1 row of 6. Okay, so I have 3 rows. In every row there are 6 plants. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So make an array. So this is an array with 3 rows of 6 tiles. And then it says draw the array you make. So what did we do? So I had 3 rows, and in every row we had 6. Three rows, every row has 6. Okay, now find the total number of tiles. Okay, so the first factor in our multiplication expression, the 3 represents the number of rows. So if I have like 5 times 7, the 5 comes first, and so that would tell me make 5 rows. The second number tells me how much is in each row. So we have 3 rows, and you can circle the second factor to remind you that there are 6 in each row. Okay, so 6, 12, 18. So there are 18 tomato plants. And so it says now, math talk. Does the number of tiles change if you turn the array to show 6 rows of 3? So here we have 3 rows of 6. And then over here, they turned it and made it 6 rows of 3. So that multiplication problem would be 6 times 3. Well, this is the same numbers, just different order. So I didn't change the number of tiles at all. I didn't add one. I didn't take any away. All they did was change it. So this is the idea of commutative property of multiplication. And it doesn't matter in which order we multiply our factors, we'll get the same answer. So okay, let's go on to our next problem, page 120. Okay, and in this one it says use 8 tiles or 8 counters and make as many different arrays as you can using all 8 tiles. So find 8 counters. Okay, here's my 8. And it says the first one was done for you. So they made 1 row of 8. Okay, 1 row of 8. 1 row of 8 is the multiplication problem 1 times 8. Well, what if we made 8 rows? Okay, so now I have 8 rows, and in each row I only have 1. So 8 times 1 is 8. So this one would look like this. Okay, so now, is there another way of grouping all 8? So remember that we have to have the same amount in each group. So here I have equal groups. So what do I have? I have 4 rows, and in every row I have 2. So the multiplication problem would be 4 times 2, and I still have the 8. So if I turn it, now I no longer have 4 rows. Now I have 2 rows, and in each row I have 4. So my multiplication problem for that would be 2 times 4 equals 8. Okay, so let's draw these. 4 rows of 2. And in every row, I have 2. In this one, I have 2 rows, and in each row, I have 4. Okay, so how many different arrays can I make using 8 tiles? I can make 4 different arrays. All right. So now they give us a picture, and we have to decide what the multiplication problem is. So what I like to do on the array is actually just put in the numbers of rows. So here I have 2 rows, and in each row I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so I have 2 rows of 10. 10 plus 10 is 20. The multiplication problem would be 2 times 10 is 20. Number 2, write a multiplication sentence for the array. How many rows? I have 3 rows. Each row has 1, 2, 3, 4, 5, 6. So I have 3 rows of 6, and 3 rows of 6 equals 18. Number 3, I have 2 rows, and in each row I have 1, 2, 3, 4, 5, 6, 7. So rows come first. How many in each row? And 2 times 7 is 14. Okay, page 121. Write a multiplication sentence for the array. One, two, three. I have 4 rows. Every row has 1, 2, 3, 4, 5. So what's that multiplication problem? 4 rows of 5, 5, 10, 15, 20. 4 times 5 is 20. In number 5, I see that I have 3 rows, 1, 2, 3, and every row has 2. 3 times 2, 3 rows of 2 is 6. Okay, number 6, draw an array to find the product. Okay, now here, the second factor in the multiplication expression tells me how many in each group or in each row. So I know I have 3 rows. Okay, so there's my 3 rows. Every row has to have 6. So 3 rows of 6. Well, we've already solved 3 times 6 on another problem, and we know that that's 18. Okay, number 7, 4 times 7. The second factor tells me how many in each row. So I'm going to start with my 4 rows. Okay, so there's my 4 rows. Every row must have 7. 3, 4, 5, 6, 7. And just continue to add 7 to each row, or make sure that each row has 7. Okay, so 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. So 4 rows of 7 and 4 rows of 7, 7, 14, 21, 28. Number 8, 3 rows of 5. Okay, so the first number is how many rows. The second number, how many are in each row. Five, 10, 15. Number 9, 4 rows of 4. So 4 rows, that's the first factor. 4 rows. Every row has 4. 4 rows of 4. And 4 rows of 4 is 16. All right, number 10, use 6 tiles. Okay, so I'm going to use 6 counters. I'm going to use my pennies again. And it says make as many different arrays as you can using all the tiles. Well, just the way I set this out, I see I have 1 that's 3 rows of 2. And I know that if I turn it, I still have 6 tiles, but I have a different array. Now I also have 2 rows of 3. So now is there any other way I can use all 6 tiles making equal groups? Well, what if we do just 1 row of 6? I could do that. 1 row of 6 is 6, which means I can also turn that, and instead of having 1 row, I could have 1, 2, 3, 4, 5, 6 rows, and in every row I only have 1. Okay, so draw the arrays. So we have 1, 2, 3. So we have 3 rows of 2. We have 2 rows of 3. We have 1 row of 6. And we have 6 rows of 1. And those are our multiplication problems. Let's go on page 122. All right, use the table to solve questions 11 and 12. Okay, so again, let's look at our table. We're looking at Mr. Bloom's garden, and he has different vegetables. He has beans, carrots, corn, and beets. And he plants these vegetables in different arrays. In the beans, he plants 4 rows of 6. The carrots, 2 rows of 8. The corn, he planted in 5 rows of 9. And the beets were in 4 rows of 7. Okay, so using models. Mr. Bloom grows vegetables in his garden. Draw an array and write the multiplication sentence to show how many corn plants Mr. Bloom has in his garden. Okay, so I'm going to draw the array right here, and I'm going to find corn plants. Corn is 5 rows. So 5 rows, and in every row there's going to be 9 plants. Okay, confirm that we have 5 rows, 1, 2, 3, 4, 5. And in every row we have 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have 5 rows of 9. And we can skip count by 5s would be easier. 5, 10, 15, 20, 25, 30, 35, 40, 45. Could Mr. Bloom have planted his carrots in equal rows of 4? If so, how many rows could he have planted? So carrots. He has 2 rows of 8 right now. 2 rows of 8. Okay, so the picture for 2 rows of 8 is 2 rows of 8. Multiplication problem is 2 times 8. So we know that he has 16 carrots. So now he wants to put them in 4 rows. All right, so 4 rows. Can we make that so he has equal amount in each group? So let's add another row of 4. Okay, so that's 8, 12, 16. So yes, he can. He would have 4 rows of 4. Mr. Bloom has 12 strawberry plants. Describe all the different arrays that Mr. Bloom could make using all of his strawberry plants. The first one is done for you, 2 rows of 6. So 2 rows All right, so we have 2 rows of 6. That's 12, right? We know that we can turn it. So instead of 2 rows of 6, we would have 6 rows of 2. So we just turned it sideways, so we can have 6 rows of 2. Now, are there some other ways we can use the 12 and have equal groups? Well, I know one. We can make 1 row of anything, and it would be equal. I mean, it goes off my book and everything, but so 1 row of 12, 1 row of 12, or turn it and we could have 12 rows of 1. Okay. So 2 rows of 6, 6 rows of 2, 1 row of 12, 12 rows of 1. Can I make groups of 4? I think groups of 4 adds up to 12. 4, 8, that's 12. So what is that array? I have 3 rows and 4 in each row. So 3 rows of 4. And you might be getting recognizing the pattern that if I have 3 rows of 4, I can turn it. And instead of 3 rows of 4, I should have 4 rows of 3. Okay. So those are all the different ways we can make 12. Elizabeth ran 3 miles each day for 5 days. How many miles did she run in all? Shade the array to represent the problem, then solve. 5 days. So 5 days of 3. 1, 2, 3, 4, 5. And in each day, she ran 3. 5 days, 3 miles each day, 3, 6, 9, 12, 15. Okay, so that's it for today's lesson. You'll now do your online work, and as we mentioned at the end of every lesson, make sure you use your textbook to use as a model to help, because the problems will be very similar. You can also watch portions of the video to help you if needed. You can also stop and ask me questions if needed. So until tomorrow, we're going to discuss the commutative property of multiplication. And so until then, good luck on today's assignment.